Alright, so here's two examples. First we want to find of gram to mole and mole to gram conversions. So we read question 1, how many grams are in 1.5 moles of sodium carbonate? So the first thing that we need to ask is which conversion factor are we going to need to use to convert between grams and moles? And so based on our chart that we drew before, we know we're going from mass to moles, or we're going from moles to mass, and so we're going to use this first conversion factor where we've got the molar mass in grams over 1 mole. So we're going to need to calculate the molar mass for any compounds that we would be using that equation for. So in this case, we first need to start. We want to know how many grams there are going to be, so we're going to end up wanting our answer in grams. We know we're starting with 1.5 moles of our substance, and so we need our conversion factor, and so that's going to be our molar mass, and so that's going to be our molar mass in grams over 1 mole. And so what are we going to want to have on top? Are we going to want moles or grams on top? Hopefully you guys all said you want grams on top. So put the grams on top and 1 mole on the bottom. Now we need to calculate how many grams that's going to be per mole, and we're going to get that by calculating the molar mass. So our molar mass for sodium carbonate is going to have 2 sodiums at 23 grams, or 23 atomic mass units, plus 1 carbon at 12, and 3 oxygens at 16. So if we calculate what that would be, we end up getting 106 grams. And so when we calculate this out, now we're going to calculate 1.5 moles times 106 grams per 1 mole. Our moles are going to end up canceling out, and we're going to be left with our answer in grams. So this is going to equal 159 grams of our sodium carbonate. And that would be our answer for the top question. For the bottom question, we're going to go in the opposite direction. We're going to want to find out how many moles there are. So that's what we're going to want to know. We know we're starting with 62 grams. And so we're going to want to use the same conversion factor because we're still going between mass and moles. So we're still going to want to use number 1 conversion factor because that's the one that helps us determine if we're going between mass and moles. This time, however, we want to calculate moles, so moles is going to need to be on top, and the molar mass is going to need to be on the bottom. So we can set up our conversion factor here. We'll have 1 mole on the top, and our molar mass in grams is going to need to be on the bottom. We need to calculate that for calcium chloride. So our calcium is very close to 40, and our chlorine is very close to 35. So if we round those guys and calculate our formula weight, or the molar mass, we end up getting 110 grams. So we can put that down here in our equation. Now when we go to calculate, grams is going to cancel out, and our answer is going to be left in moles, which is what we want to find. So this is equivalent to 0.56 moles. And again, we need to put the formula in here of calcium chloride. So this is how we use our first conversion factor from mass to the moles in equations. We use our molar mass in grams over 1 mole. Let's take a look at a couple of problems using Avogadro's number next.